two forces act upon an object as shown. We have this rectangle here and these two vectors applying to it. This is just a horizontal line, so that doesn't have any effect on the vector. It's these two vectors here. Question: what is the approximate magnitude of the resultant force? So a couple of vocabulary terms. First, I'll start with resultant. Resultant is a sum of vectors. So it means we're adding up multiple vectors. Magnitude would be like the hypotenuse or the radius. It's the power, if you will, that comes out of these two vectors. So what we need to do is add the two vectors together. Now, there's multiple ways of doing this. We've learned that from psi y cos x, that sine theta is the same thing as y over h or r, depending on which letter you want to use, and that cosine is x over h. And if you were using like an old school calculator, you could just multiply by h, and here multiply by h, and we could get the x and y values that make up a vector. Remember, vectors are in component form are x and y, and so you could just say the h, which in this case is 15, that's the magnitude, times cos of 20 and sine of 20, and then you could do the same here. Or our calculators have the ability that we can just use these brackets and put in h theta. So we would tell for the first vector, it has a magnitude of 15. And then the angle, you have to put the angle symbol in there. And we'd say this is 20 degrees going up from the horizontal like this. And then we would add it to the other vector. Now here's the key. This vector is going down. Since it's going down from the x-axis, this is actually going to be a negative 27 degrees. So we would add the vector. That's a magnitude of 12 with angle negative 27 degrees. If we type that in the calculator and press enter, it'll calculate it for us. So let's go over here. I'm going to go to calculator, do control parenthesis, that gets the bracket. We have 15, comma, to get an angle, we press control book. And there it is in the second row. I just realized. There you go. Let's try this again. 15, comma, control book, angle. And the first angle was 20 degrees. So let's choose 20. Make sure we put in the degree symbol, just so no matter what the mode is in our calculator, which mine is in degrees, so it should work either way. But just to be safe, we always type that in. And then control bracket for the second vector, which had a magnitude of 12, and its angle, press control book, was negative 27 degrees because that angle was going down from the x-axis. When I hit enter, this will give me the resultant. The resultant is something with a magnitude of 24.79, we'll say, 24.79 at a negative 0.3 degree angle. So that's what we get here, 24.79. And this would be in pounds, followed by a negative 0.3 degree angle. That would be the direction angle, but we're not interested in that. It said only the magnitude. So the answer here should be B.